2024 has already been a wild year in AI, and we're already getting even better coding models. Now, you're probably wondering, does Phixtral have anything to do with Mixtral from Mistral AI? And the answer is kind of. The only real similarity between Phixtral and Mixtral is that they both use what is called a mixture of experts architecture. And that's important because before Mixtral had not seen used outside of OpenAI and some models from Facebook. And the idea here is you have a bunch of different, quote, expert models in different things, and then you have a router that understands the prompt, and then it picks the best set of experts to give you an answer. And Maxime Lebon, an AI developer on Twitter, decided, why don't we just try this with only coding models and just create a coding-specific expert model only built with models that are good at coding. So the models used to make this are not from Mistral, and the architecture is different enough that actually we're not going to see a GGML port of this for a while, but you can run it on a T4. And later in this video, I am going to demo actually using this model. So the cool thing is we can actually use it. It's a pretty novel approach, and I'm very excited to tell you guys more about this. So welcome to AI Flux. Let's get into it. So just a few hours ago, Maxime Lebon released Phixtral, what he's calling the first efficient mixture of experts model with phi-2 models. And phi-2, for those of you who don't know, is a very powerful coding model that came from Microsoft and that has been fine-tuned to a pretty insane degree in the last few months. And basically, Phixtral combines 2 to 4 fine-tuned models and is better than each individual expert. So in short, the idea of leveraging mixture of experts models is when you strap all these together and you force a router to kind of choose which one is the best to send something to based on an input prompt. They're really only worth it and called efficient when the aggregate performance of a mixture of experts model actually outperforms any one of the expert models it's selecting from. Because obviously at that point, you'd be better off just using one of the experts themselves. And the idea here is that each expert is good at its specific thing. So in the case of Mixtral from Mistral AI, we had experts for math, we had experts for prose, we had experts for programming. And the idea is that when you lap all that together, you get better performance doing that than just giving it a ton of information and hoping it just understands connections between all of those in one aggregate model. That was what we used to think in early 2023, and researchers have learned a ton since then. So the idea here is get 4 or 2 really fine-tuned, powerful models for coding and see how they do. So how did they do? I'll link below to these 2 different Phixtral models currently available in Hugging Face. It's important to note again that there is one version with 2 experts and one with 4 experts. So how good is this model? So there's been some benchmarking done, and in the following days, we're going to get more and more information. So these are the benchmarks for a Phixtral by 2. So basically looking at 2 experts coming from phi-2, and this is using the Nos research benchmark suite, which I think is quite good. They're not coming from kind of a corporate approach, so you can assume the bias here is going to be less pronounced than it would be otherwise. And he says here, a big thanks to Vin62s for the inference code and dynamic configuration for the number of experts. That's kind of what makes a lot of this work. What's interesting here is it is in most cases better than Dolphin 2 and phi-2. Not by a huge margin and in only specific areas, but I think it's quite interesting. And it's important to note that the benchmarking suite on Nos just runs a bunch of different benchmarks. So on average, this is more performant than basically all these other models. And it's really cool to be seeing a mixture of experts model actually outperform a DPO model, which in theory, DPO models should have more focus and be able to understand connections between similar contexts within the models they're using. And that's a really big thing in programming because obviously you have to relate, asking for a website to do something or asking for a certain function that interacts with any number of other functions. Those kinds of connections are made better in theory with DPO. So it's cool to see a mixture of experts model actually performing well here. It's important to note that all of this would not be possible without some really cool new tooling called MergeKit. Basically, what MergeKit tries to make easy is the interop between different LLMs and how you can make them more similar to then use them in, for instance, a mixture of experts model. It doesn't necessarily change the structure of the data going in, but it's a really cool piece of tooling. And if you tried to do this with models before, MergeKit makes that a lot easier. And it's important to note that the models that actually make up all 4 of the experts in the by 4 model, and I'm not sure which 2 are actually used in the by 2 model. These models are Dolphin 2, phi-2 DPO, phi-2 SFT DPO GPT-4. So basically this is a model that has been enhanced with actually outputs from GPT-4, which is kind of interesting, and phi-2 coder, which is one of the original phi-2 versions that came out. And again, he mentions here that there's no GGUF yet, because the architecture is something that hasn't really been approached yet in force by the GGML masters of like the Block AI or ggRNV. And what's interesting is there is, however, a Google Colab notebook that runs at 4-bit precision. So you can actually use this in a Colab on a T4 GPU right now. I'm probably going to do a dedicated video on Mixtral architecture itself because Mistral has just released their official academic paper trying to explain why they think Mixtral is so much more performant. It's also the first open source paper that focuses on Mixture of Experts models. And again, basically the idea here is you have a router that takes inputs and decides where to route them. A really interesting attribute of these models, as opposed to just bog standard LLMs, is that they're actually gating weights as long as inference weights. So when you hear weights, you normally think, oh, like that's what the model is trying to decide what to focus on or what to infer on, and it's a very high level understanding of this. But what's cool is with Mixture of Experts models, there's actually another layer, which are gating weights, where it actually weighs whether or not the expert it provided input to provided a good enough output, and then uses that to compile a singular output. And what's cool, and I'll link below, is that Phixtral Chat is actually currently available as a free demo on Hugging Face. So that'll be linked below. And now let's go try it out. So I have some specific coding questions I like to ask these models. I'm going to start with some easy ones and then move into some that are a little bit harder. I'm not really going to use programming questions because, quite frankly, they're just too easy for these models, and most of the data sets they use are like lead code data sets. So let's see here. Write a function to estimate the distance between 2 points in 3D space. And it'll be interesting to see how performant this is. I assume this is also running on T4 instances. Cool. So this gave us a naive implementation of Euclidean distance. That's pretty cool. Now let's ask something new. Let me try something a bit more complex. Let's see, create a React.js landing page using Tailwind CSS. Include say to scale for mobile users. So this is a bit more open-ended. Let's see what this does. So obviously, since this is running on a T4, the inference is going to be a little bit slower than something like GPT 3.5 Turbo. But there have been a few other instances of this I've put in, but I've made some other prompts, and I've gotten code that's worked on the first shot right out, which has been pretty cool. Basically, all I wanted to see here was that it would figure out that since I wanted it to scale for mobile, it would include media queries. And it did. And for my last prompt, let me give it something that I actually ask as an interview question when I interview engineers. So this one is, if I provide you a list of points with x, y coordinates, each with a letter tagging each point, write a function that can tell me largest circle I can draw, center at 0, 0, that contains largest number of points that do not have the same tag. Assume duplicate tags can exist but represent different points. So there's some sorting in here. There's some understanding of a number plane in 2 dimensions. And this is actually something that ChatGPT 4 honestly struggles with. So I'll be interesting to see what this does. Okay, so it's making a default dict to sort the list. We're iterating through all the lists. We're iterating through the list of points. So it's maybe missing that Euclidean distance is actually the way you answer this, but we'll see. Okay, so it's calculating the distance to 0, so that's not entirely wrong. Let's see here. It's counting how many points. Now there are a bunch of for loops, so it's not going to win in terms of how long this would take to run, because that's 3 nested for loops, and that's not great performance, but we didn't tell it to be efficient. We'll actually ask that as a follow-up. And okay, cool. So it's going to give us some test cases. Sometimes these models will cheat and they actually won't give you a real test case. The only other problem here, and this is my fault, is I didn't tell it 2 tags can't have the same point. So that's one potential issue, but minor. We'll let it finish here. Points are sorted by their x and y coordinates. The points at the same tag. Okay, so it sorted by x and y, not by Euclidean distance, but that's not entirely wrong. So let me just ask it, is there a more efficient way to implement this function? Just give it a hint, less for loops. The other funny thing is a phrase like less for loops is also a really good kind of heuristic test for a lot of these LLMs. Because if you think about it, like if you just told someone less for loops and you didn't know what a for loop was, that would actually be pretty confusing, and it actually isn't even a valid English sentence if you look at it without understanding what a for loop is. Because you're not throwing something for a loop, you're not looking for more for loops, you're asking for less for loops. And you could think that, also if you were an LLM, that this was a human asking for less loops, like serial or something. But let's see here. Okay, so it's figuring this out. It's going to use a sweep line algorithm. Not a bad choice. Where the input points are sorted. Okay, so it's assuming they're sorted, but that's easy enough. Not a huge reach there. And now it's going to give us the setup here. Let's see what it does. All right, and here's the function we got. So I put this in, and this actually didn't quite function right, but what's cool is it's maintaining context with the same test case, which is cool. I don't think these models can actually execute code since they're not rigged up in the same way that GPT-4 is, which is more of an integrated approach. But this is actually much more impressive than when I've used phi-2 and when I've used GPT-4. Because what's funny is since I have to do interviews these days, there are times where I'll actually just take the questions I'm going to ask and I'll put them into GPT-4 or phi-2 and just see what comes out. Obviously, I wouldn't fault someone if they had a similar approach, because I think these interviews are kind of a dumb way to gauge someone's intelligence. But for testing LLMs, they're great. And honestly, this is pretty impressive. I'm going to mess around with this locally and see if I can get it running faster. Right now, the only downside I can see with this is the speed. But yeah, I implore a lot of you to try running this. I'll link this along with the Google Colab that runs on T4 with the 4-bit quantization below. And yeah, as always, if you like our content, please like and subscribe, share with a friend, and we'll see you in the next video.